In this video, we'll explain the different methods to send structured messages, as well as how to parse the messages. So we have blocks, signals, and interface blocks are the different elements which we will be able to send from one subsystem to another. And first we'll start out with how to parse the blocks. So what we've got here is a packet of information, E, F, and G, and we have our parse packet context. So these are not connected in any way at this time. So we'll jump into the behavior of parse packet block. And we've got three different ways or methods to parse the packet. So I'll just go ahead and run this in simulation. And you can see that all three of them do work. They all parse this packet. So what's happening in the create object, which you can get by going down here and doing create object action, and then you just drag in the packet just like that, and then you would connect it to this is an opaque action, this is an opaque action. Both of these opaque actions are written in JavaScript Rhino. So the ALH is the action language helper. This is one method, and then this is another method. And just to show that it's both of them are JavaScript Rhino. And then this one is the read structural feature, which I got from just going to any action and just typing it in, read structural feature action, and then you can drag and drop the structural feature from the containment tree into the read structural feature. Something to note is that this create object only works with blocks, such as this packet block. It will not work with signals. Even if the signals have the exact same elements of data within them, it's not going to work. So if I drag this signal on here for all three of them, you're going to see when I run this, it just times out immediately. So now moving from blocks to parsing signals, we've got this setup right here, and all four of these examples that you see on the right side are different ways to parse the signal. So signals are going to require you to have this send signal action, or this item right here. Right now we don't have to determine the port because in our IBD we don't have any proxy ports, but in most cases you're going to have it sent from proxy port to proxy port and not just directly. And to fix that, you would just go into here and then type in on port, and then you would go search for your proxy port which you're trying to send it over. So we'll run this in simulation. And what we saw there, we'll run it again, is we're sending this 12 value to be put into the error count. So it's going to overwrite this 2. And then this example signal with the packet of information inside of it is going to be sent from sender to receiver. The receiver receives it, and then we're just using this state machine right here, which is the classifying behavior of the receiver. So if I double click here, it's going to go to my state machine. So, and then this ALH get value signal error count greater than 5, because it was greater than 5, it goes to S3, and you can just change this to something else, such as like 3, and run it again, and you'll see that it goes another direction. It goes to S2. So the logic does work, and it is reading the data, the value of 3 within the signal right here in the state machine. So now what we can do is we can, instead of making the classifying behavior this state machine, we can make it the other ones to show that they work as well. So we'll do that. So I'm just going to change the receiver, and if we just pull out the state machine and then drag in the second one, so now when we rerun it, it's going to use this one instead of this one, because now the classifying behavior of the receiver block is going to be receiver example 2. You'll see that there. Classifier behavior is receiver example 2. So we'll run that. and you'll see that it does work. It's using the exact same command, so it makes sense that it works. So now we'll do the same with example 3. So what this is doing, it doesn't have the logic anymore, but it's still reading that value of 3, which is the whole point. So you can use this read structural feature. So we've learned that this read structural feature is exactly the same as the first part, the ALH.getValue signal error count. That line of code is the same as this read structural feature for this case. So moving on to the 4th example. So in this one, we actually are using a different setting for the accept event action. So we have this is unmarshal set to true for this accept event action. And what that means is that it kind of automatically parses it for you. You'll see that the error count is the output versus up here, the output is just result, which is an unparsed output. So when I go in here, this is example 3, not 4. The is unmarshal is set to false. So if I wanted to go into example 3 again and just convert this from false to true, you'll see that it will flag me and say broken synchronization, and I can change that and then synchronize, and you see that now my output is error count, which is the data within the signal. This error count is the output. So if I had 2 properties, you would see that that one just automatically pops up. So I'm just going to control Z my way out of that. I think it's important to note that if we add a new property, it automatically adds to the is unmarshal set to true, but it's not going to add another port down here for result, because result is like the structure which contains all of the properties within it. So now we'll jump to sending messages using blocks. So if we're going to send messages using blocks, we're not going to be using signals, and we're going to show an example using operations. So for this, we have our sender and our receiver, and our receiver is going to have an operation associated with it called autopilot. And you can just create that by hitting the plus here and operation. So when you create an operation, it will put it down here, and then you can go into the specification for that and add a method. So the method is going to be the behavior which is invoked when that operation starts. So the inputs and outputs of the operation are going to be the exact same as the inputs and outputs of the method, which is invoked when it's used. So I'll go ahead and delete the unnamed operation. So the operation that we have associated with the autopilot operation is this example opaque behavior. And the body language for that opaque behavior is just 2 lines of code that you see right here. And that was just a screenshot. Here is my opaque behavior, and you see that the inputs are the same as the outputs between this operation and this behavior, as well as you can see the body of code, and we've got that just written in English because it's so simple. So when I run this, so I'll just pull out all of my value properties that come along with it, and when I push play, you'll see that the 5 goes down and turns into 105. So, and then it's just going to repeat. So for this state machine is the classifying behavior for the receiver, and the autopilot start is the classifying behavior of the sender. Notice that the operation, or the opaque opaque behavior, is not a classifying behavior of anything. It's just connected to autopilot. So what's happening is we're going in the sender, and A1 equals A. So A is 5, and it's just reassigning that to A1, and it's outputting that A1 into the autopilot. Now, we made that autopilot by just dragging and dropping the operation into the activity, and you can just delete the target here and then connect everything up. So what's happening is when we hit the autopilot operation, it's sending the inputs from K1, and again we have to go in here and do the on port. So I did add the on port of K1, and I picked K1 because it's going to be sending it over from the sender K1 over to the receiver to grab the operation from the receiver and then do the contents of the operation. So when the operation is complete, z equals a plus x, so z is reassigned, and so x was an initial value from our receiver, so it's 100 plus the 5 that was sent, so that makes 105, and then c equals z. C is going to be our output that is going to be returned as our result. So our result right here is 105. So if I just like continue, it will sit here and do it all over again, and we can change any of the values and it will send different values and then do the math appropriately. Additionally, if we take a negative value, you'll see that the autopilot actually changed from autopilot to manual because it was less than 0. So then it will change back right there. So this state machine for the controller still is able to interpret the changes from that z value while the opaque behavior is happening. So it's all happening in parallel. So now we'll look at our next example, which is going to be still using blocks, still using operations, but we're going to make it a little bit more complex because instead of that simple opaque behavior, we're going to have an actual diagram, which is, as you see here, the activity diagram. So we'll go ahead and run that in simulation. And then it returns that 3 value. So we started with 2 from this block. We're not using the signal at all because we're using an operation, and signals can't be used for operations. So it takes that a value, that integer 2, and it's going to send it. So we're going to create the object, send the signal input. The a value is in red, and then we just add 1 to that, and then we return 2 plus 1, or 3, and then it comes back over here and completes. So the thing to note on this is that when we run it, look down here in the sessions. Right now we've got the sender, and when this is kicked off, you'll see that it starts for a set amount of time and then it stops. So I paused, and we've got this RX signal that is happening underneath the sender. So in the previous example, when we ran it, we had 2 classifying behaviors, and both the autopilot and the system are going to just continue to run indefinitely, and you won't even see the opaque behavior happen just because it's so quick. The other difference is that this one, we are sending the entire block with all of its contents, while the previous example, all we did was send a value, so not the whole block. So there was no parsing that was required. So here's the parsing that was required for the block. So now we'll jump to using signals. So we see that we have the send signal action and then the accept event action here. So we'll run this in simulation. We're using the signal now and not the block. And that was it. So what's happened is we have added the via K1, again, the on port K1, and we've added a value specification which can be found in the actions, value specification action, and I just typed in 2 for this case. So I'll delete that, and then I've got, if you just drag the signal onto the screen, it will automatically have A and B because A and B are here. If I add another one, you'll see that it gets added as well. So that's how we made that one. The sender activity is the classifying behavior for that, and the RX signal activity is the classifying behavior for the receiver, meaning that both of these, when the activity is, or when the system is run in simulation, when I start it, both of them are running at the same time. One more thing worth noting, we do have isUnMarshal set to true for this example for the accept event action, and that's just so that we don't have to go that extra step and parse the signal. So now we'll move on to example 6. And this is going to be using interface blocks and flow properties. And so we'll go ahead and run this in simulation. And it's just going to be looping. Notice there's no behavior for the receiver. And it's basically going to be automatically updating the values on the receiver side once the sender side has been updated. So we've typed the proxy ports with interface blocks. Our interface blocks have flow properties of types integer, and then we have created an IBD, which is very similar to what we had before. All we did was show the flows that are on the interface block. I'll go ahead and stop this simulation, and we can actually like minimize all this and make it smaller and more user friendly to look at, and this is perfectly acceptable. Going back, so what we did was we used this display and displayed pretty much everything that there was to display, and then we connected the value properties of the sender to the flow properties that we want it to go over. So we've created a mapping, so it's going from A1 to this flow property across to this flow property to this A2 here. So we did have to manually create the links between A1 and these flows. So going to the next example, this example, we do not have to create these linkages between value properties and flow properties. It is created when we do this redefined flow 1. So I'll show that it works, and you'll see that it does work. So the way to get this to work is you could just click on the value property and then just type in redefine property, and this outflow 1 is what I have selected. So I'll just show what happens if I remove it. So I don't have it there now. So now we don't have the linkage between A1 and this flow 1. So when I run it in simulation, it's basically the flow 2 is working and the B2 is working, and A1 is changing because that's what's happening here, but it's not actually sending flow 1 over to flow 1 to A2 because that linkage is broken. So how we did that was we created a generalization relationship between the sender and receiver to this example interface block, and essentially we were able to inherit the flow 1 and flow 2 when that generalization relationship is created. And so then we would just go in and say that this value property is redefining flow 2, this value property is redefining flow 1, and then you have to do this on this side as well. So if we add this here, and I'll just show one more error state. If I remove the redefines flow 2 here, this will be another error state. So I run it. So you can see that it's sending the values from the sender and through the port over to this one, but there's no connection between flow 2 of the receiver and B2. So that's why it's not actually working. Lastly, you can type flow properties by blocks or by signals. So that is totally acceptable. I'll go ahead and leave some links in the description below of other videos which inspired this video, which is going to be related to sending messages from subsystem to subsystem.